All right, folks. So check this out. Here's what we got. What I'm gonna do is, it seems like a lot of you folks need help on this homework, and I don't want to move things too far back, but I don't mind moving it a little bit further back. Let's see. Algebra 2. You have. Okay, let's see. Okay, I'm gonna make this due on this day. And I'm going to push everything back by like a day. There. Let's refresh that and see what we got. Oh, and it looks like you guys were struggling on this 1.8 stuff, huh? Why don't I take the 1.8 stuff and make it due on tomorrow as well? Yeah, that sounds like good. All right, so your 1.8, 1.9 is due on that day, and I'm assuming you folks already took all of your chances. So let me go in after and give you guys like maybe another couple of, I don't know, we'll see. All right. That way I can lecture on what I want to lecture today, and then I can have the chance to go over other stuff. So let's get this party started. Let me archive this, start the recording. All right, so we're going to start off with this thing called the laws of exponents, and this also should be review for you, although you might not have seen it exactly in this form before. And that's fine. To me, it's kind of like the laws of exponents that make sense. They make a lot of sense to me. And I don't memorize it like this, but I'm going to write it down like this. So if I have like x to the m times x to the n, that's the same thing as x to the m plus n. If you have, now in an exponent, this is called the base and this is called the exponent. If you have different exponents but the same base, then you keep that base the same and you add the exponents together. It makes a lot of sense to me because if I have like x squared times x cubed, then I think to myself, okay, well this is x times x, this is 2 x's multiplied together, and I'm multiplying it by 3 x's. So how many x's do I have altogether? That would be x to the 5th power. Does that make sense to you? Sure, I've seen this before. Now, write down this equation and at least be able to recognize it when you see it. All right, there's a division rule, and I kind of, all right, it's x to the n divided by x to the m is the same as x to the n minus m. The way I like to think about this is, let's try this. That would be like x cubed divided by x squared. Well, that's x times x times x divided by x times x. And so this would cancel out with that, that would cancel out with that, and you would have only one left over, so you would just have x to the 1st power. Yeah, you subtract the exponents. That kind of gives rise to what happens when you have these exponents in the denominator. When you have these exponents in the denominator, what you could do is you could kind of think of it like this. This is how I think of it. X to the n times x to the negative m. Because if you look at your law of adding exponents, or you're multiplying two numbers that have exponents, that gives you the same thing. That gives you x to the n minus m. So equivalent, mathematically, this is the same as this. Does that make sense? All right. The next rule that I want to show you is the exponential rule. So if I have an exponent to an exponent, x to the m to the n, that's equal to x to the m times n. I like this rule as well, even though I'm not used to necessarily seeing it like this. I like this rule as well because you can kind of think of it like if I have x cubed squared, well that's x cubed times x cubed. Look, it's the same base, and in this case it's the same exponent, but as long as it has the same base, we're good. That would be x to the 6th power. You could get there a lot easier if you just multiply 3 times 2. You get 6. Boom, done. We cool with this rule? You understand where this is coming from? All right. The zero exponent rule. X to the 0th power is equal to the number 1. Now, why is that? You know what? To be honest with you, I can't remember. I remember learning this, and I can't remember why it is. But it is. I mean, that's just kind of the thing that you need to assume. No, it's not that nobody knows, and I even remember reading a good discussion on it. But actually, there's a good reason for it. Let me get back to you. And Lucas, let me kind of tap into something you said. You said provided that that x itself is not 0. So let me ask you this: what is 0 to the 0th power? Bradley says 1. I'm assuming that Lucas is still saying debatable. The answer is it's 1. And yes, Lucas, I've seen people debate this, but I think that there is a right answer in this debate. And the reason being is because anything to the 0 power is 1. And if that weren't the case, then a lot of the mathematics that we've built off of is going to fall apart. So it's almost like that discussion that we had about, like, well, what happens if slope is not rise over run? What happens if slope were run over rise? Well, things would work until we work with other people, and then it would fall apart. Like, it's kind of by convention. So the answer is 0 to the 0 power is still the number 1. I know, it's crazy. All right. The negative exponent rule is anything, so I can, and we touched on this before, is x to the negative 5 power is the same as 1 over x to the 5th power. You can turn this negative exponent into a positive exponent if you reciprocate it. So, like 2/3 to the negative 4th power is the same as 3 over 2 to the positive 4th power. Does that make sense? So I changed it from a negative exponent into a positive exponent, but I had to take the reciprocal of that. No. And Lucas, don't feel bad for not knowing that 0 to the 0th power is equal to 1. I've seen people really debate that topic, and I mean, it's interesting. All right, here's another question. If A times B is equal to 0, okay? What's up, Acacia? Just sit down. Yeah, go for it. All right. If A times B, and what's going on? I've got actually Acacia coming in and hanging out. Do you want to? Or
they could see me.
All right, here we go. They can see me. I don't care. All right, start sharing. All right. Now, this is an important concept, and I'm sure that this might seem easy to you, but it's important. So I've got me and Acacia. Acacia, scoot in. All right. So if A times B equals 0, let's pretend that I have a secret number. I don't know whose book this is. All right. I have a secret number written on my hand. And Acacia has a secret number written on her hand.
It's true.
Yeah, you see it?
Yeah.
It's there, right? We see it. Okay. Now, I can tell you this. I can tell you that my secret number times her secret number equals 0. What can you conclude about that?
Can I answer?
Yeah, you can answer.
Does that mean one of us has 0 as our secret number?
Either one or both of us have 0.
True.
Right? So if you could have 1 billion written on your hand, or you could have whatever number you want, and like it written out so long that it takes up all of your finger, and you know, I mean, it's all over the place.
My arm, my sleeve.
Yeah, but I have the number 0 on my hand. Then me times you is 0, right?
Mm-hmm.
Or I could have a really long number, and you have 0, and me times you is 0. Or I could have had 0, and you could have had 0, and that could have been the case. That's an important that's an important concept that we're actually going to tap in today. So I know that that might seem, I know that that might seem trivial almost, but it's actually, I mean, we're going to come back to it, and you're going to say, "Oh, okay, I see why you've taken this time to have this discussion." All right, what is Graham's number? That's a question that Sophia's asking. Sophia, I'd love to get a chance to discuss that, and here's my answer: is tomorrow we're having a tutoring session at 11 o'clock. Why don't you ask me that during the tutoring session? It would be a good question to ask. Cool. That would be a good place for it to go. All right. Let's see. I have a few of these laws in here. Yeah, this is good. All right. All right, so I'm going to turn this back to me. And let's see. A times B plus C equals, now this is called the distributive law. You folks know this already. A times B plus A times C. We cool? All right. You guys got that? Okay. So here's another thing. I'm going to ask you, I'm going to go over this probably pretty quickly, but I think that you folks might know how to do this. Let me ask you, A plus B times C plus D. Okay. I'm going to kind of approach this problem just like what I did up here, up on top. So I've got something times C plus D. Cool? So I'm going to write this out as A plus B times C plus A plus B times D. It's exactly what I did up on top here. Now, I think that a lot of you folks are getting to my point already, and that's cool. But I'm just doing this slowly so that way everyone makes sure that they know what they're doing. Then what I'm going to do is I'm going to distribute the C into here and the D into here. So I have AC plus BC plus AD plus BD. Are we cool? And I think I'm going to rearrange this just a little bit. I'm going to write this as AC plus AD plus BC plus BD. All I did was I switched these insides over here. And I can do that because of the commutative property of the thing. And this is the technique that we're going to use when we want to multiply two binomials together. So when we're multiplying two binomials, we end up with something that's actually called a trinomial. And I'll explain to you what that is. But in order to do that, all you do is you do what you guys call the FOIL method. You do the first, outer, inner, last. So if I have A plus B times C plus D, have you heard of the FOIL method? Do you guys remember what the FOIL method is? Yeah, it's the yeah. All right. So this might have, remember, this is algebra review. So hopefully this is all review for you. This would be the first times the first, which would be AC. The outers would be the dudes on the outside, so that would be AD. The inners would be BC, and the last would be BD. Are we cool with that? All right. So x minus 1 times x plus 2, let's try it. X minus 1, x plus 2. If I were to FOIL, you don't remember how to reverse FOIL. And actually, Bradley, I think that that's an Algebra 2 topic. So if you covered reverse FOILing in Algebra 1, then your teacher was actually going over Algebra 2 stuff. So that's in my realm. I should have the responsibility of teaching you how to reverse FOIL, also known as factoring. You might have learned that before, but that's fine. Anyway, let's do this one. Let's do first, outer, inner, last. This would be x times x, which would be x squared, plus 2x minus 2. So this is my first times the first. Here's my outer, here's my inners, and here's my last. Did I move too fast for anyone? Now, if you feel like this might be like, oh, hey, he's moving fast, and you feel like everyone else in the class is getting it because it seems like everyone else in the class is getting it, don't feel free at this point to speak up, because if not, you're going to get lost behind. The whole point of me going over and spending all of this time doing review for you is so that we can make sure that we have these concepts down. Cool? All right. Now, I'm going to combine these are the like terms over here, so that I see a x or 2x minus an x. So if I have x squared and then I have a 2x minus an x, I'm left with just one x left over, minus 2. So this is my answer. And a binomial is something with two terms. So I told you I multiplied two binomials. Here's 1 and 2 terms. And then here's my second binomial, 1 and 2 terms. And I end up with a trinomial, 1, 2, 3 terms left over. Usually when you multiply two binomials together, you end up with a trinomial. Are we cool?
Did you spray something?
No? What?
Do you smell it? It smells like scope or something.
I use scope.
Oh.
Oh.
I thought it was that smell that the elementary people were getting a while ago.
Yeah, no, that's not me.
It's actually scope.
Yeah, no, I
Good job.
try to be winter fresh.
Good.
All right. All right, I'll tell you what, why don't we do a few of these for try. And I'm not sure if this is your homework. If it is, then I apologize. I'm actually doing your homework for you. All right. Is there crazy lightning right next to you? Because there's none for me right now. All right. 3x squared times 4x4. All right. So what I'm going to do is I'm going to multiply the numbers first. So I'm going to go with 12. Now I'm going to deal with the exponents. X to the what power? X6. Awesome. And you can figure that out because you have an x squared times an x4, same base, different exponents. The exponents, you add them together. Good? All right. 2 over 4 x to the 4th power x cubed. I like to deal with the numbers separately. That's a 1/2. The reason being is because these exponents aren't tied to that 2. This 4 exponent is tied to the x, and this cubed exponent is tied to the x, but not the 4. So I can kind of separate them out. So I have 1/2, true. And then what I'm going to do is I have x to the 4th power minus x cubed, or x to the 4th power divided by x cubed is the same thing as x to the 4 minus 3, which is x just to the 1st power. So my answer is 1/2 x. Does that make sense? Good with that? Okay. I'm glad you said no, because I feel like I'm going fast and no one's slowing me down. Essentially, x to the 4th power divided by x cubed, I can write that x cubed, since it's in the denominator, I can make it into an x to the negative 3 and put it in the numerator.
Oh, okay.
Got it? And now I have my same multiplication of exponents. I have the same base, an x and an x. And I have different exponents, so I can make that x to the 4 minus 3, which is x to the 1 power. That's why I have an x there. You can also think of it as x to the 4th power is 4 x's on top. X to the cube power is 3 x's on bottom. 3 of these guys on the top gets canceled by all 3 of these guys on the bottom, and you have x left over.
Oh yeah, I got that. I thought
Yeah.
it was something else.
This is the way easier way to think about it, but it's better for you to kind of wrap your mind around that, because you can't always draw a picture.
Mm-hmm.
Okay? All right. Yes, I agree, Mark. This is the better way to think, or not the better way, but this is the more, when I'm first teaching this to you, is what I would do. But what happens if I have x to the 73 power minus, or divided by x to the 42nd power? I don't want to write 73 x's up on top and 47 x's on bottom and then cancel them all out. See what I mean? So then you just realize, oh, that's just 73 minus 47. Done. Got it? All right. let's do this one. 10 over 2 x cubed over x to the 5th power. I'm just going to tell you the answer. You tell me if you guys got to agree with me. I say it's 5x to the negative 2. Also written as 5 over x squared. Personally, I like it this way the best. Sophia, that's something different from what you got. Why did you get it messed up? Just curious. Sophia actually got the exact inverse of what the answer is. We good with this one, though?
Yeah, what does that mean, though?
What do you mean?
Exact inverse?
Well,
Opposite, or?
Sophia got 1 over 5x to the negative 2. That's what she wrote down. Because she wrote 1/5 x to the positive. This is what she wrote down. 1/5 x squared, which is actually, this is my answer, this is her answer. Her answer is flipped upside down of my answer.
Yeah.
So it's interesting that you got the inverse of what I got. I don't understand how you did that. But the 10 divided by 2, that's 5. x3 over x5, that would be x to the 3 minus 5, which is x to the negative 2. That's how I got my answer. Good? I know, I'm moving quick. All right, let's do this one. 2x cubed. That would be, now this whole time I've been kind of treating the numbers separately, but look, this cubed acts on that too. It also acts on this x cubed. So I see that as 8 x to the 9th power. Where did I get the 8? Well, 8 comes from 2 times 2 times 2. That's the 2 cubed part. So that would be 2 times 2 is 4, times 2 is 8. Good. The x cubed is actually x cubed. That would actually be x to the 3 times 3, because I have an exponent to an exponent.
X times 3. Okay.
I'll show it to you the easier way. X cubed is the same as writing x cubed times x cubed times x cubed. Right?
Oh, yeah.
So this would be x cubed times x cubed. That's x to the 6th power, x to the 9th power, because I've got one more after that. We good? All right. This is all review, and I know I'm going over it pretty quickly. I apologize if I'm blowing you folks away, but I think that this is pretty straightforward stuff. X times x minus 1, what does that equal to? Well, that's, distribute that x in there, and I've got x squared minus x. Done. Cool? All right. I think the rest of it is foiling some things. Oh, here's a good one. I like, let's do 7 and 9. X minus 1 times 2x plus 1. All right. You ready? EKG, you want to do this? Help me out with this one?
Are we foiling?
Yes. See, what I appreciate about you is, even though I put you on the spot, you're willing to at least just try. And know that Mr. Dalde will try to support you and not ridicule you. Okay? So x times 2x is what?
2x squared.
2x squared. Perfect. The outers would be...
What is that? Negative
x
1
times...
and then positive 1?
No. The outers means this guy on the
yeah.
outside times this guy on the outside.
So that'd just be x. So plus x.
Plus x.
First outer inner. So then would be negative 2x.
Negative 2x. I see you folks typing in answers. I appreciate that. I'm just writing this down for... I want to make sure everyone in our class can do this.
What is that? If would that make a negative 1?
Negative 1 times positive 1 is negative 1. Yes, I agree. Now I combine the middles and I have 2x squared minus x minus 1.
What'd you combine?
I combine these two guys right here because they're the same. They're like terms here.
Oh, yeah. Okay.
And the x minus 2x, if I have 1x minus 2x's, I'm left with negative 1x. Does that make sense?
Yeah.
Okay. And so that's my answer. All right, here, let me try this one with you. X minus 1 squared. This should be pretty quick and easy for you. Okay? It would be x squared plus 1. Because I square this and I square this. Everyone agree? All right, yeah. Yes from Sophia. Yep, yep, good. Okay. I'm just making sure everyone gets it, so as I went pretty quickly on that one. All right. Lucas is saying something I don't... Oh, yeah. Exactly, Lucas. I got the +1 because I had the -1 times -1 is +1. Yes, I agree. Everyone agree. Say, come on, I need audience participation here. Awesome. Good. Cool. Okay. You're all wrong. Everyone's wrong. Bad wrong, in fact. Don't ever do that again. And I'll tell you what, I'll make a deal with you. The next time you folks make that kind of mistake, I will put my foot into the camera, it will come out of your camera and boot you in the face with my dirty rubber slipper. Don't ever make a mistake like that. I'll show you what's going on. I tricked you. I'm sorry. I apologize. But at least now, remember, Mr. Dalday says these absurd things and does these absurd things so that way you can remember, you know, these equations. And I'm telling you this now because it's super important. X minus 1 squared is the same as x minus 1 times x minus 1. Okay? In fact, I'm going to make a, you know how you folks have all of your OMGs and the LOLs and the ROLFW or something like that?
Yeah.
I'm going to make one. I'm going to call this the BTTF. Next time you folks make that mistake, it's a BTTF. And everyone we're going to make up our own, whatever they're called, their you know, abbreviation. It's called a boot to the face. That's what you get. All right. So, x minus 1 times x minus 1 is actually, this is the same as this. And I'm not tricking you. Everyone can agree with that, right? If I FOIL this, this becomes x squared minus x plus 1. Agree or disagree? Now this combine these two guys in the middle, and that becomes x squared minus 2x plus 1. That is the answer. It's not this. It's this. And it actually is very close to this. It's just the thing you're missing is what we call, it's called a cross term. It's this term that kind of appears. So don't ever make that. So if I ask you something like this, what is a plus b squared? Don't, and then I told you, oh, isn't that a squared plus b squared? Everyone agree? Everyone agree? And then you folks say, yeah, I agree, and I would write down, boot to the face.
And then just don't talk until someone figures it out.
Yeah. BTTF, my friends. Yes, that will be our class, the abbreviation our class makes up. That's our contribution to society. Boot to the face,
That's
BTTF.
actually a good one, though.
Yeah, it's pretty good.
That's a good reaction to anything anyone could say.
Yeah, just like boot to the face, dude. All right. So, and the reason being is because it's a plus b times a plus b. So that would be a squared plus ab plus ba plus b squared. Am I losing anyone with what I'm writing down here? This is the first, outer, inner, last kind of deal. You got it?
Mm-hmm.
Okay. Everyone else got it? All right. And then I can combine the guys in the middle, because believe it or not, those are the same. A times b plus b times a, which is the same as a times b, right? So I have a squared plus 2ab plus b squared.
So it doesn't matter which, like, I guess, order the variables are coming in. They're still the same if it's the same two letters.
What Ikasia is asking is, hey, how can you combine a plus b, or a times b plus b times a? And my answer to that is this. With multiplication, there's this rule called the commutative rule. And it basically says that if you have multiplication, you can multiply in any order you want. For example, 3 times 4 is what? 12. What's 4 times 3?
12.
12. So I could switch those around as long as there's multiplication in between them.
Oh yeah.
And I'm down. I'm game. Yeah. I didn't flip them, I switched them.
I thought.
When we say the word flip, we're either talking about a Filipino or we're talking about reciprocal.
I thought that those were just one little thing.
Yeah, no, we're talking about switching. Yeah. And by the way, I don't know. I kind of regret saying that flip comment because I don't know if that's offensive. But then again, I'm Filipino, so maybe it's one of those things where I can say it because I'm Filipino.
Yeah, probably.
Yeah. If I offended you, I truly apologize. Anyway, all right. Let's do this one. Where did my last name come from? I think my last name is Filipino. I believe it is. All right, let's see. This looks like it's from your homework. So I'm not going to do this one. Although I might do maybe this one, number 9. Let's try that one. X times x minus 1 times x plus 1. All right. This one's an interesting result. And Sophia, are you talking about 2.3 as in the past homework, or what are you talking about? Anyway. All right. Algebra 2.3. Why don't we cover that tomorrow, if that's all right? I don't have a whole lot of time because I got to start chemistry at in 10 minutes. All right. Let's look at this. Let's do this one. X minus 1 times x plus 1. Because this actually might give you a surprising result. X minus 1 times x plus 1. What is that equal to? Okay, well that's equal to, first is x squared, right? Outers is what?
What does that say? 1. It's 1. It's just x then plus x.
So it's just plus x. Yes, Mark. I'm archiving this as we speak on 2 different mediums, so we can go back to this. What's the outer? Or what's the? What's next? Is the inners, right?
Negative x.
So it's negative x, and then what's the last?
Minus 1.
Minus 1. So look, I combine the middles, and so I have x squared. What's x minus x?
It's no x.
It's 0x. It's nothing there. Minus 1. Interesting. X squared minus 1 is also written like that. That's an interesting thing. I'm just gonna accept it for as it is right now, but I kind of want you in the back of your head to think, that's an interesting result. All right. Anyway, I only did this part of that equation so far, right? I still have to multiply whatever I got as my answer by x. So if I slap on an x in front of this, then I got to remember to distribute this x into here. So what I'm looking at is x cubed minus x. Because x squared times x is x cubed, and negative 1 times x is negative x. Are we cool? All right, so we taught you how to FOIL. Hopefully you knew how to FOIL. Okay, all right, here's what we got. Here's the last bit of it. And this is why I made such a big deal about that me and Acacia thing. If I have some secret number written down in my hand, and you have some secret number written down in your hand, then and I told you that it multiplies out to be 0, then the answer is either I have a 0 or she has a 0 or we both have zeros. Okay? So, if I have something like this, x minus 4 times x plus 10 equals 0, then what can I conclude? I can either conclude that x minus 4 equals 0, or x plus 10 equals 0. No, it's not, Lucas, it's not that one of the x's might be 0. I'm saying this number times this number is equal to this thing times that thing is equal to 0. It's either thing 1 is equal to 0 or thing 2 is equal to 0. Does that make sense?
But wouldn't that require one of the x's to be equal to 0?
No, it wouldn't require one of the x's to be equal to 0. I'll tell you what it would require. It would require that one of the x's is equal to 4. It also would require that or one of the x's is equal to negative 10. I just took this 4 and I added it to that side, so it's positive 4, and I took the 10 and subtracted it over to that side, and it's negative 10. If I plugged in x equals positive 4, that would be 4 minus 4, which is 0, times 4 plus 10, 14. It doesn't matter what the 14 about the 14 because the first part is 0. Does that make sense? So the whole thing is going to be 0. Or your answer could be negative 10, because this would be negative 10 minus 4, which would be negative 14, multiplied by negative 10 plus 10. Negative 10 plus 10 is 0. So it doesn't matter what the first one is, because the second one's 0. So if I gave you this, then your answer, you would tell me, is either that this is 0, or that the first one is 0, or the second one is 0. You would have two answers you would have to give me. Does that make sense? All right. After a while, you're going to start to see a pattern. How does 4 relate to negative 4? It's just the opposite of it, right? What about 10 and negative 10? What do you see? Just the opposites. Let's try this. What is x to the 1/4 times x to the 9? Or not to the, but x plus 1/4 times x plus 9 equals 0. If I were to, oh, hey, Lucas already got the answer. Lucas says x equals negative 1/4 or x equals negative 9. And I would agree completely with Lucas. Agreed. Does that make sense? All right, let's try this one. What about 2 times x minus 4 times x plus 10 equals 0? Ooh. What is this answer? Sophia says x equals 4 and x equals negative 10. But wait a second, I got a question, Sophia. That's just like the first answer we got. In fact, that's exactly the first answer we got. Why didn't it change? Because there's a 2 in front of it.
Because you'll still be multiplying it by something that is 0.
Well, actually, this is kind of like having 3 things equal to 0. It's A, B, or C. It's either A is either 2 is equal to 0, this second one is equal to 0, or the C is equal to 0. The third thing is equal to 0. Now, 2 equals 0. Is that ever a case? Is that ever true? No, so we kind of throw it out. We kind of said, you know what, 2 doesn't equal 0, so it will never be that case. But it's fine because this is an either-or situation. It's either this or this or this. So if I throw one of them out, that's fine.
Can't it be like, I don't know if this is right, but I mean it's simple math, but can't like x be negative 6 maybe?
X be negative 6? Well, if you plug in negative 6 into here, this would be 2 times negative 2 times 4.
Negative 2, but there wouldn't be a 0 in there.
Yeah, no. I see where you're getting at. You're thinking that the 2 and the negative 2 make 0, right?
Yeah.
But remember, you're multiplying all of these together.
Oh, undo.
No. That's a good try. All right. Let's see. What about this one? 2x times x plus 10 equals 0. What are my zeros? What am I getting at here? I would say x equals negative 10. That's good. That's only half the answer. Or x equals 0. Agreed.
Oh, yeah.
Because look, if I plug in a 0 for x, then 2 times 0 times 10 is still 0. So I set this thing equal to 0, or I set this thing equal to 0. And I'm done. Are we cool with that? Now this is the mechanics of the thing, but really, why the heck is Mr. Dalday teaching you to do these things? And I'm going to run out of time, but I'll tell you what, chemistry students, you can wait 5 minutes because I do want to cover this with you. Let me Let me go over to the quickest graphing calculator I can find. I'm just going over to a graphing calculator. Sophia, what are you saying? Oh, yeah. You said x equal to well, you said x equal to 0, or you said x plus 10 equals 0. Yes, at the same time. It's an either or statement. You're setting one or the other equal to 0. And let me just type in. Oh, wait. 1 second. What happened? 2x times x plus 10. 10. 1, 0. 1, 0. All right, check this out. What this does is this kind of equation will be a parabola, if you can see this parabola. See the parabola? And what I was asking is, when does that equal to 0? When is the height equal to 0? And we can see immediately from this. Oh, shoot. Okay. Well, then class is finished. Ta-da! It's 2:15.
What just happened?
I don't know. Bummer. I was on a roll, and then class finished.
Oh, like class literally just stopped.
No. This computer crashed.
Oh.
So
It's
see you in chemistry.
Well, are you going to be able to do chemistry?
Yeah, we got to do chemistry now. I got to fix the problem and switch.
All right. Okay, I'll see you tomorrow. Well.
No, you're not. Oh yeah.